In this video, we'll introduce the idea of absolute extrema, and you'll also hear them called global extrema from time to time. As a first step, I want to talk about the definition of the absolute extremum, which are our absolute maximum and our absolute minimum. I want you to pause the video and try reading this definition and understanding what it says. So reading the definition, it says, let f be a function defined over an interval I, and let c be some value in that interval. We say that f has an absolute maximum on I at c if f of c is greater than or equal to f of x for all x on that interval. And we say it has a minimum on the interval at c if f of c is less than or equal to f of x for all x in that interval. All right, and if it has either an absolute maximum or an absolute minimum on that interval, we say it has an absolute extremum on that interval. We'll look at some examples now to see what an absolute maximum and an absolute minimum look like, and then cases where we might not have an absolute maximum or an absolute minimum. All right, let's look at example A. In example A, we do not have an absolute maximum and we do not have an absolute minimum. Neither of those things exist. And so let's concentrate first on the absolute maximum. Notice that this function is defined on an open interval. So as x gets larger and larger, this function's values also get larger and larger. And the way we can write that is as x goes to infinity, f of x also goes to infinity, right? It goes to positive infinity. And so we don't have an absolute maximum value. Likewise, as x goes off to negative infinity, f of x also goes to negative infinity. So we don't have a smallest value. And so that's the problem here is we have an open interval, so we won't have an absolute maximum. We won't have an absolute minimum. Let's look at B now. In B, we do have an absolute maximum, and you can see that that absolute maximum is right here. That's the highest point on the function, or that the function takes on. And one thing I want to note right now is that the absolute maximum occurs, absolute max occurs at x equals 0. But it has a value of f of 0, and that's 1, right? So the absolute maximum is 1, and it occurs at x equals 0. I want you to make special note of how we answer these questions. Some students mistakenly say that the absolute maximum is 0. It occurs at 0, but the absolute maximum is actually 1. So you can see this with your own eyes. It's easy to identify an absolute maximum. In this case, we do not have an absolute minimum, though, because, again, it is defined on an open interval, and as x goes to infinity, this value, although it never goes to negative infinity, it gets smaller and smaller, and it's going towards 0, isn't it? And it gets even closer to 0, so it's getting smaller and smaller. And as x goes to negative infinity, the function, again, gets closer and closer to 0. So even though we can't say 0 is the minimum because it's not actually reaching 0, it's just getting smaller and smaller. So again, in this case, we have an absolute maximum at x equals 0, but no absolute minimum. In the third case, C, we have an absolute maximum and we have an absolute minimum. And notice that the absolute maximum happens here, and the absolute maximum, again, we would say is 1. And it actually happens at multiple places, doesn't it? It's going to happen, assuming that this function goes on and on, the absolute maximum is 1, and it occurs in an infinite number of places, doesn't it? And the absolute minimum is -1, and it also occurs in an infinite number of places. So in this case, we have an absolute maximum and an absolute minimum. In the fourth scenario, or D, we have a piecewise function, and in this case we have an absolute maximum, okay? We have an absolute maximum of 2. You can see that's the highest point, and it occurs at x equals 0. And in this case we have no absolute minimum. Why do we have no absolute minimum? Well, it looks like the absolute minimum, some people might say it occurs at -2. that the absolute minimum is -2. But actually, since there's an open circle here, it's getting infinitely close to -2, but it's never reaching -2. So we cannot say it has an absolute minimum. It has no absolute minimum, and that's because it's an open circle at that point. Let's look at problem E. Problem E is defined on this closed interval. So in this case, instead of the graph continuing on to infinity and negative infinity, we've stopped it. We've said it only happens between 1 and 4. And so we can see that the absolute maximum is here. And we would again write the absolute maximum is 4, and it occurs at x equals 4. Just happens to be the same value. And the absolute minimum, don't say this is not the minimum. This is not the minimum. Okay, that's not the minimum. The minimum actually occurs here, right? That's the minimum. The minimum is 0, and it occurs at x equals 2. And again, or finally, with example F, we have this function. It's defined on this interval here from 0, so it's partially closed. It includes 0, but it doesn't include 2, and that's because as it gets closer to 2, it shoots off to infinity. So in this case, we have no absolute maximum. Why? Well, as it's getting closer and closer to 2, it's shooting off to positive infinity, isn't it? So it's getting larger and larger, those values. However, we do have an absolute minimum, and the absolute minimum occurs at x equals 0, and it has a value of 0. So the absolute minimum is 0, and it occurs at x equals 0.